Good morning, everyone. Welcome to another episode of Xa Talk Show. Today is 2021, November 15th. So, we have a topic. I'm thinking this is going to be a work session. I'm going to work on my Xali website and lots of to-dos. So you're gonna learn some coding. Wolfram language or PowerShell. So let me ask you guys a question. Answer right away, okay? Right now. Do you want me to use Wolfram language or PowerShell? Answer that question right now. Okay, so let's go to do. So I'm going to work on my website and lots of coding. It's basically live coding. So I'm going to do, let me explain what I'm going to do. So, okay, so you go to Ergo Emacs, okay? You go to my Emacs blog, so search for, so you can see there are a lot of links to xali.info. Now, that is fully qualified domain name, fully qualified URL, okay? So you can see this is a link to, here's a Wolfram language tutorial. So let's show in browser, search for Wolfram. So I'm blogging, October 31st. I'm talking about now coded Wolfram language for several months. Now, I think I revert a Lisp opinion. Certain technical details about Emacs Lisp, symbols. Okay, you can read that. Okay, so this is my Emacs blog. Okay, and on this section, I have links to my Wolfram language tutorial. For example, click on that Wolfram language tutorial. Now, go back. Now, before my Emacs blog, my practical Emacs tutorial is hosted on the website ergoemacs.org. But a month ago, as you've seen in my live tutorial, I have moved it into xali.info. You can see in the URL. So now it's all on xali.info. Therefore, this link is to a local, it's in the same domain. So I do not need the fully qualified domain name. So let me show you, for example. Now, you see this text block. Now, by the way, on the pink window, you can see all my Emacs command call, the command names, and all my keystrokes, such as moving cursor or any keystroke I type corresponds to a Emacs command, and you can see the command name there. Okay, so let me turn on global highlight mod so you can see my current cursor position. So anyway, so you see this text block or paragraph. Now I want to extract all the URL. So I press a key, done. You can see the command is XHTML extract URL. If you search that, you'll find the source code, probably. Or just use XHTML mod. Pay me, okay? Pay me and you'll get it open source. So I extracted the URL in this paragraph. Now I go down here, paste it. You see, fantastic. Now I can make a link. You see, it's a link. Now, or I can make the whole thing into a list with local files linked. Okay, so do it. There you see it. You see, fantastic. Now you can see this paragraph and this paragraph are actually the same. You see it, almost the same. They link to the same file. So, but over here it's using relative links. So I can press enter to open it, show in browser. There it is, Wolfram language, syntax and operators. Okay, back to Emacs, close this page. Same thing for this page. Enter to open it, show in browser, Wolfram language tutorial. Back to Emacs, close that. Now, same thing here, except they use fully qualified URL, domain name. So if I press enter, it's actually going to the Xali website. So anyway, what I want to do for 2000 files, 2000 HTML files in my Xali domain name. So you can see you can go up, you can see this is XARD domain name. Now hide the Unix thing, the Unix crap. So XARD domain name directory, then search for Emacs. There's a Emacs directory, lots of files. Hide the Unix. Then there's Emacs, you see, so 700 files. Then there is miscellaneous, 200 files. So basically, about 1,000 files in this, about 1,000 files. Every link that is linked to xard.info using the fully qualified URL, I want to change those links into the relative links, okay? So relative links like here. And also, you see, change the link text into the title of that page. Okay, that is the task. Now, the question to you guys is that, should I do it in Wolfram language or PowerShell? Let's see, comments. Hi, Xardi, hi. Wolfram sounds interesting. Okay, Benjamin says, okay. Then Ragheb says, what are your thoughts on Copilot? Okay, that's crap. Okay, that's shit. Copilot, today's one of the fad they announced, GitHub or whatever. They say, oh, we are going to have AI code the code for you. That's crap. That's completely bullshit. Okay, that's just marketing. It's not going to do shit, except it's going to do enhanced completion. That's about all it does. Okay, so let's do Wolfram language then. Two people say it's Wolfram language, and Vice Q, good morning. So, okay, so let's do Wolfram language. Now, this is going to be a kind of big task. It's going to take 1 hour. So before we do that, let's have a cold brew coffee. Enjoy the elite life in America. To harmony and prosperity. Peace for the world. I injured my finger, I talked about in my past few videos. Cold brew coffee, supposedly to be better, but I'm not a coffee connoisseur. I don't know the difference. So Wolfram language. Okay, so this is gonna be a hard topic. Okay, I mean, so this is going to be a live session, a work session, coding session, live coding session. Okay, so let's write down what we need to do. For each HTML, let's magnify file in a the. Now, if you have questions, comments, post it. Okay, I love to see your comments. Your comments gets the flow, gets the talk show. So for each HTML file in a directory, find all links that uses fully qualified URL of xard.info of http://xard.info. Change them to relative link. Okay, so that is the task. Okay, showing browser, you can see magnify for HTML file in a directory. Okay, so let's go back to Emacs blog. So let's show an example. Copy that here, delete that, close that, yes, paste it here, and okay, let me just work on this so you can see the workflow. Show the pink window so you can see what I'm doing. So you can see, showing browser, there are two links. One is the fully qualified domain name, one is relative link. So example, okay. Where is my for example? for example, change this to this. Okay, now showing browser. Now it's, you see the HTML, it's better than org mod. Xafly keys with great keyboard. Kinesis Advantage 2 keyboard. This one, this fancy Batman keyboard, and this is ultimate hacking keyboard. I use it for macro. So macro keypad. You see that new tab, close that. We don't need that. So you can switch tab backward, forward, close it, reopen it, things like that. And Emacs bookmark, jump to XA keyboard blog. You click on here and you go there, buy it. Okay. Now let me mention. So Kinesis Advantage, they are going to have a new keyboard out. So a little digression. Okay. Let me show you. Kinesis Twitter. JavaScript is not available. Okay, let's turn on JavaScript then. You want information? I'll give you information. So Kinesis Advantage, you know, this maker of Kinesis keyboard, this one, fantastic, my favorite. They are coming out next year, sometimes next year, with this new model. You know, after now, by now, from 1990s. So Kinesis first came out in 1994, something around there. So after 25 years, now they have a new model. So this is how it looks like. Okay, so you can go to their website. They have a photo. It's not out yet, and I'm going to review it. Okay, I'm going to give you guys a review of this new keyboard next year. But now, for now, you can go buy Kinesis Advantage. This model right now, they have a Thanksgiving discount, 20% or 15%, I forgot. And also, you can use my code. Okay, what's the code? Okay, let me type the code. Okay, so digression, a little digression. Add okay, copy the URL here, paste it, linkify, by discount code, okay, XAH. Okay, so you go there, you go to the Kinesis Advantage website, you can give them a discount code XAH, and you'll get 15% off or 20, I forgot. And plus today, Thanksgiving, they have a discount. So I'm not sure my discount applies over the Thanksgiving discount. But anyway, so keep the comments in flow. Okay, keep the comment incoming. I want incoming comments. Keep it flowing, guys. 6 person watching, not much. Okay, so that's about the Kinesis Advantage keyboard. So they have a new, so they have a new one. So let's close that. So now let's go back talking about what we are doing today. So you can see, change this link to this link, but let me do something else. Okay, so let me show you. So I want the browser to show the actual HTML code as you have seen on this Emacs buffer. Okay, so how do I do that? Okay, watch. So I add a code. So this is HTML code. You can see showing browser. Now it's empty HTML. Magnify. Let's see the complete beauty of the font. So now it's empty. Now copy that, paste it here. Okay, showing browser. Okay, that's still not the source code. So now I do this. There it is. Now showing browser. You can see now this is the actual source code. Yeah, you see, that's what I want to do. So now we don't need this part anymore. So let's do the same here. So HTML and syntax correct. Go to the browser, refresh. There it is. So change this links of this form to this form. Okay, let's do Wolfram language. My God, Wolfram, let's begin. This is gonna be 1 hour because I haven't done much text processing tasks in Wolfram language. Let's say 1 plus 2, enter, 3, good. Magnify the font. Okay, Wolfram language, we're gonna code this today. So, okay, so working session, okay, there's not, okay, so I have to, now I have to think, okay. So for every HTML file in a directory, you want to, traverse, get every HTML file's content. In that content, open it. In that content, find links, find all text of this form. You can use a regular expression. Then change it to a relative link. Okay, so this is gonna be a work. This is gonna be a lot work. So Wolfram language. Okay. Okay. Let's see notes. Okay, how okay, so any comments, questions? How hard is to type on conventional keyboard after you get to use Kinesis 1? It's same thing. There's no like stumble. I mean, what there's no. I mean, once you learn the Kinesis advantage, so normally you might think, okay, once I get adopted to this Kinesis advantage keyboard, then when I switch to laptop keyboard or a normal PC keyboard, I'm going to be clumsy because the keyboard is all different. No, that does not happen. Okay, that a little bit maybe, but for example, because once you go back, it doesn't. Okay, so it doesn't happen. That's not a concern. Don't worry about that. What you want to worry about is, for example, if you actually use a different keyboard layout, such as Vorak, QWERTY, Comac, then you might worry about that. Because once you adopt Vorak, then you cannot touch type on QWERTY unless you keep practicing both. Similarly for Comac, Walkman, and all the other keyboard layouts. Okay, that answers the question. Now let's get back to the Wolfram language coding. So let's focus on this. Okay, Wolfram language coding. So you want to open every directory. So coding notes. So let's write some coding notes. Okay. What? So you have some coding notes. So we the directory we want is, let's start to code. Okay, Wolfram language. Now I'm using let me show you. I'm using Wolfram language mod in Emacs. Okay, there are two ways to code in Wolfram language. You can use Wolfram language notebook. You can buy Mathematica, or you can get it free. I talked about. Xali Wolfram. Search for it. You can go to, okay, so all these are my websites, all these are my past tutorials, lots of videos, about Wolfram language. So you click on that Wolfram language tutorial. There's, I still work on, I make betterments of these tutorial every day. So I highly recommend that, let me repeat this. Watch my past tutorials. I've done more than 10 Wolfram language tutorials. Then you have Wolfram script, what it is, and let's turn on JavaScript. So you can see there is a refresh. You can see my past videos. What's the difference between Wolfram Engine, Wolfram Mathematica, Wolfram script, and where do you download it for free? You can buy a Raspberry Pi. It's bundled with Raspberry Pi free, or you can just download the Wolfram engine free. Okay, and then you go to the top, the home page. So I have tutorials, I have several, lots of videos. Some, many of them is not shown here. It's on YouTube. Okay, so that's Wolfram language. So now we want to, for example, let's, usually I use my own tutorial. So in Wolfram script tutorial section, I have a collection of kind of idioms or functions that you want to call when you want to do shell-related tasks, such as getting, traverse the directory, find and replace, those kind of tasks. So I have collected the function names. So first of all, let's start to code. Root, okay, root directory equals to a file path. Okay, so file path xali. Let's limit it to Emacs. Okay, let's get the root here. So file xali.info Emacs. Okay, let's just try that directory. Okay, that's a root directory. Then I want the function file names. Okay, so you see I'm coding Wolfram language in Emacs using Wolfram mod. If you like what I do, buy it, support me. So let me show you. Describe key, press the key for invoking Wolfram language mod. Then you can see here is the mod name, Wolfram mod, and here is the source code. Press enter to go to it. There is a source code, 2,500 lines of code. Go to the top, you can see there's a URL homepage. Open it, show in browser, Wolfram mod. Search for it, you'll find it, and pay me, you'll get it. Okay, so because coding in Wolfram language, it's much more efficient when you work in Emacs, of course, because Emacs is designed for it. I mean, the Wolfram notebook allows you to have interactive graphics and play sounds, or sort of that. I'm not going to show it today. So okay, Wolfram language mod. Okay, so wait, go here. Open last closed. Copy the URL back to Emacs. Go to talk show, SAS talk show, and paste the link. Make a note so we have a record of what we talked about today. Okay, so that's Wolfram language mod. Okay, so now, and close that, copy that, already there. So what's Emacs blog? Okay, copy the Emacs blog, paste here, make a record of what we talked about. Copy that URL, paste it here, and close that, go here, copy that, back here. Conjoin the lists. Okay, showing browser, you can see here's today's topics. Okay, back to coding Wolfram language. Now you go to open this file. We were coding that. So file name, you want file name takes 3 arguments. Okay, the first argument is star HTML. That's a string. That means I want all star HTML files. Okay, file names ending in HTML. Okay, then the second argument is the path. Okay, so put it here. That will list all files in that directory. Okay, so let's try it in here. You can try it, run it. Okay, wrong. Why is it not showing? Oh, okay, file names, not file name. Okay, thank God. File name. Oh, there's a different function. Okay, so what is so what does file name do? Let's show. Let's go to. Oh, file name is actually illegal syntax. Wait, but why is it? Okay, that's a bug in Wolfram mod. Let's fix it. Okay, go to the source code, list matching lines, list all lines that contains the word file names. Okay, so there it is. Now, why is there a file name? Okay, so anyway, let's go to Wolfram mod. Let's see. So that's illegal syntax. Yeah. Okay. File name is, there's no such function file names. Okay. So you wanna, so how did I get this? Must be my mistake because Wolfram language functions. Okay. Okay. Make a backup. Go to the directory. You can see here is all my packages. Delete the backup. Well, okay, here's all my packages. XAL Emacs packages. You can buy them. Again, support me. Git status, git add, git commit. Okay, that we just made a change to XAL Wolfram mod. Okay, close that. Okay, now file name is not file name. Okay, copy the code, go back here, select all, paste, run it. You can see tons of files, thousands of files. Okay, go to the top. Okay, so that lists file names. Then, then you want recursively. Yeah, so recurse, the third argument is how many levels of directories you want to go to. So if you just say 1, how many directories you want to go to? So let's give it, you can say actually infinity. That infinite future. What does infinite future do? Let's look up documentation. Infinite future returns a date object expression representing infinite future in time. Fantastic. This is what Stephen Wolfram likes to talk about, how Wolfram language is symbolic. It has a symbol representation of just about every notion. So, you have a notion of future, right? I mean, you have the notion of a future. So in Wolfram language, you have a symbol or function that represent that notion. So when you talk about future, there's there's an immediate future and infinite future. So you gotta, it returns a date object that, it returns a date object expression that represents infinite future in time. So why do you need this? For example, when you compute date time calculation, there's tens of functions on date. Okay, date interval, date absolute time, date winter Q, date within Q, date overlap Q. So there's tens of functions on date. So when you compute with dates, just not like average typical languages, at most they give you date differences, like given to date, you can calculate how many days between them. That's almost the best they can do, the most advanced thing about date they can do. But in Wolfram language, I tell you, you have infinite future. So I can tell you, for example, time, you got date object, time object, date interval. Okay, so if you click on date object, it can give you, because I was looking at this yesterday, let's turn on JavaScript so we can see the full glory of the website. So you have date object, then you have all these different formats familiar to most of you, date, month, ISO format and so forth. But then you also have calendars. You have like all possible calendars encoded in Wolfram language. You can do it easy. Okay, that's a bit digression, but you see, from Julian date, then you have time series, event series, current date, date round, Unix time, from Unix time, Julian date, from date string, calendar convert. Okay, like when you specify a date, you can say what calendar. I mean, even obsolete calendars, Egyptian calendars, and all that. So I was looking at this. That's a nature. That's the nature. That's a characteristics of Wolfram language. They embody everything. They essentially, that's what they say. Stephen Wolfram likes to say, it's the computing and knowledge combined. All human knowledge, all algorithms. You don't have to code it yourself. There's a function already does it. So that's a digression. Okay, so let's go back here. So so here is all the files. Okay, lots of digression. So let's let's continue this. Okay, so this is not infinite future. I want infinity. So infinite future, infinite line, infinite past, infinite plane. You can have a plane in geometry. You can have a code that represent infinite plane, not just typically finite. So I want infinity here. Infinity represent the recursion, like recurse the directory. Okay. So now let's say files equals to, okay, so we got a list of files. Okay, then for each file, let's see file map. Okay, for each file we need to do something. So map, there's also file map. File system map. Okay, file system. Let's see what's the difference. Usually you can just do map to files. Okay, file system map. Hello, Tiago says, have you ever tried Sage? Yes, I have. So what do you think about? That's a common, frequently asked question. Sage compared to Mathematica. Sage is crap. Okay, the worst. A magnitude, not just the magnitude. If you compare programming languages, let's say Haskell or something, some good programming language, Haskell, Clojure, Julia. Okay, those are very high quality programming languages. A magnitude better than C, C++. Okay, F#, Haskell, Julia, Clojure. For example, these are the best languages, or you can skim this if you want. Okay, now these best languages compared to Mathematica is a magnitude beyond them. Okay, one line in Mathematica equals to 100 or 10,000 or literally 100,000 lines of this Haskell or whatever. But when you compare Sage is worst crap. Okay, that's open source thing. Yeah, Sage is free. Go download it. Then you spend hours trying to do whatever fuck. I can show you right now, but it's a digression. That's why I blame. I don't. That's why you open source fanatics. You don't know nothing. Yeah. Anyway, so that's a digression. Sage. Just use if you want. I recommend Wolfram language. But there's a competitors to Wolfram language, to Mathematica. For example, Maple. Okay, I can recommend. If you really want, if you want to be a mathematician or physicist, you want to focus on your learning, on knowledge, on your career as a physicist or whatever, or engineer. Like mechanical engineer, chemical engineer, scientist or engineering, not programming. Okay, if you are an engineer, scientist, you want to get a tool that helps you do your stuff, focused on your career or whatever, learning. Okay, or solve problems, solve equations, or even MATLAB. Okay, I would even recommend MATLAB than Sage crap, open source fuck. So you want to focus. So yeah, but if you like open source, if you are open source fanatics, Unix philosophy, Unix, Linux, open source, tiling window managers, if you are, if you think your life, you want to be an open source proponent, open source activist, yeah, go ahead. You're gonna waste your life on that, with no benefit. Do it, go ahead, try Sage. Yeah, actually, I recommend you try it yourself. Try it. Don't trust me. Go download Wolfram Engine, free. Go download Sage. First of all, try to see how long it takes for you to start to write your first line of code, 1 + 1. Okay, try Sage. Download. How long it takes for you to see what's going on. Okay, so that's a digression. Open source fanatics, fuck. idiots. So back to a system map. So I want to see what file system map actually do. At this rate, we cannot finish. So many digressions. At this rate, it'll take 2 hours for me to finish. How long have I been talking? 15 minutes. Okay, so let's continue. So I want to know what's the difference between file system map. Normally I would just say, here's what I would do, okay? Normally, map a function to files, process, okay? Process file, okay? So this is a function we have to define, process file. For example, let's define it, okay? Process file equals to function, okay? Then path, file path, then do whatever. Let's say print, okay? Not principal components, print, okay? Print path, okay? So here is a function definition, and I can map this function to the files. Files is all these files, right? This is what I do normally. And here, the body of the function, we open the file and find all the links with the xali.info URL and find and replace them. Then make a backup and save the file. That's what this function will do. Okay, so we can start to document this function. So process file, this is the way you document it, I believe. Okay, so I forgot what's the syntax. So let's go back to Wolfram language tutorial. Let's see what's the syntax for function documentation. So search for string function. Okay. So this is my tutorial, list all functions. Okay, so let's search for documentation. Okay, let's search for docstring. Okay, so this is how you write docstring. Okay, not message, usage. Okay, copy it, close that. So this is actually what you want, not message but usage. Okay, so delete that. So I'm documenting this process file function. Open the file, change all links to xali info, change all links to all xali http://xali info to be relative link and of file at path, and save and make a backup. Okay, so that's too big a font, so let's shrink a little bit. Okay, that's the documentation for this function. Okay, let's put the documentation in front. Okay, so now we can map the file. So that's normally what I would do. Map this function to all these list of files. But what is the file system map? Let's look. Okay, file system map. froot, okay, gives an association whose keys are the names of files in root. Okay, association, which is a hash map. Okay, which in Python it's called dictionary. So, or in Perl, Ruby, it's called a hash table. So it returns a hash table or dictionary whose keys are the names of files in root. Okay, so the keys is the file name, in that root directory, and whose values are the result of applying f to the full names of these files. Okay, so f will returns something. Okay, anyway, it returns a hash table. That's not what we need. That's not what we need. Map is what we need. Okay, map. So right now we can actually run the code. So select all, paste it. That's too big. Okay. That will actually you see that will that just prints the file path. Okay, so you see yeah, it prints a lot file path. It just prints them. And so why is the slash and backslash there? Let's see. Yeah, it returns null because when you print, the function returns null. Okay, it just printed, but the return value is null. So let's go back here. So actually, let's not say print. Let's say the path. Let's get the file name part of the full path. Okay, so how do you do that? Go to Wolfram language tutorial. Go to Wolfram script tutorial. So you have list files, current directory, delete directory, check if it's a file or directory, check file directory existence, directory path, file name, file existence, file extension. Okay, that's what we want. So we want file base name. Okay, so this is a function, file base name. So instead of print here, we want file base base name. Okay. Okay, so copy that, select all, paste it. Okay, put a semicolon here. Okay, copy that, select all, paste it, run it. Fantastic! Now you just got a list of file names. You see, now it's just all list of file names. You see, fantastic. Now we are getting closer. Okay, now open file. One of the tasks. The way I code is that I logically dissect the problem. So now we have basically the structure. Now we need to refine the process file function. So what will it do? First of all, it needs to open a file, get the file content. Okay, so how do you open a file, get the file content? So there is a tutorial here. Get file date and time. Okay, file size, print file content. There it is, file print. Okay, but except I don't want to print, I want just the content. So read string. There it is, read and get file content, read string. So okay, read string. Now let's look at the documentation. Press a key, you'll jump to it, show the pink window. Reads the complete contents of a file and return it as a string. So yeah, so you can give it a file path here. Okay, so we are refining our function here. Now here's the function body. Now we want, let me show you something else. Okay, module. Okay, so what modules do? This module function is a way to create local variables. So in Lisp, that is called let. In Common Lisp, Scheme Lisp, Emacs Lisp, you have the function let. The purpose of that is for you to declare local variables. So in Wolfram language, that's module. Okay, so we can put the code here. So module, so you want to, so what local variables we want? File content. Okay, file content. Then you can say file content equals to restring. Okay, so in fact you can define it here. You can define it in one shot. Okay, file base name we don't need. So file content. So now we got the file content. Okay, now you want to do find and replace. Oh my God, this is gonna take a long time. This is gonna take another hour. Find replace. Okay, so am I doing good? How many people are watching the paucity of XR Talk Show? Nobody is watching. 6. Say something. So now we want to do find replacement. Okay, now write to file. Okay, so there's several things we need to do. These are the things we need. Write string, write to file. Okay, comment it out, and string replace we will need soon. But right now we need to, string replace. Actually, we need string replace. So content, so string replace. The first argument is a string, right? So string. Okay, the second argument is the part you want to replace. Now, before we do replacement, we need to know. Before we do replacement, we need to know, for example, XR Talk Show. Let's go to XR Talk Show. Your explanation so far is excellent. Thank you. Thank you for the comment. So you see, we want to replace, let's magnify, okay? So we want to replace text of this form by this form. And so first of all, we need a regular expression to match that. Once we found the match, we need to generate the relative link. Now, in order to generate a relative link, you need a path directory of what relative to. What is it, relative to? So you need the current file path. So let's write down what we need to do. So, wait, what? So in my Wolfram mod, I don't have the indentation. So what do we need to do? We need current file path, current file directory, because we need to calculate the relative to the directory. Then current href value. Okay, current href value should be that domain name, that full domain path. Okay, so we get the current. So this is actually fairly complex. So we get the full domain name. We need to turn the domain name into a local full path. Okay. Then we can calculate the relative path. Okay. Convert domain path to local to full file path. Okay, that's what we need to do. Okay, so there are things we need to do. So there are several things we need to do here. My Emacs, my XR Wolfram mod is, there's no indentation, so it's hard to read. So let's go back to Wolfram language, copy or paste it. So now here you can see much better. Yeah, but then you know the comments got screwed up. Yeah. Let's try it again. Yeah, it doesn't work. Okay, so you know comments in Wolfram language is problematic because it ignores all the line breaks and that. Okay, so but shit. Let's do this. Okay. Select all, paste. Okay, that's a little bit better. So let's do it one thing at a time. Current file path we already got. This is that path. Okay, let's change it to full path. Okay, so that's current file path. Let's rename again. Let's say current file path. So now we have the name current HTML file path. Why do I use the elaborate name? Because later on it's gonna be fairly complex because you have the current file path, current file the href string, value string, the domain name, then the file path of that domain name. So you need the names to be clarify them. So current so how do you get the current directory? So how do you get the current directory? So let's see Wolfram language tutorial. So what is this to do? Close. So Wolfram script tutorial. Yeah, we don't want that. Wolfram script local file. Yeah, so how do you get the current directory? So I mean not that. You want to get the directory part of a full path. Okay, here. File name drop. Okay. File name drop. Okay. Actually, we got okay, actually all these things should be inside module, so it should be all here. So file content. Okay, file content, then the path. Current path. Okay, so that's how you get current directory path. So current file path we have, current file directory path we got, then current href value. So just joined in. Okay, so we are coding. Yeah, so let's see. Module is a local variable. So these are the local variables. So we got the file content. We get the file content, current directory path. We got the current directory path. Then you need to have a current href value. So how do you do that? So now you need to do find and replace. So okay, so So the actual part is the find replace, string replace. String replace this text, this string. So now you need a regular expression. Now we need a regular expression to represent these things. So so there's a lot to do. So we need a regular expression to represent this. So how do you do that? Yeah. Now I haven't used Wolfram language regular expression before. Now let's go back to Wolfram script tutorial. Find replace. Okay, so where do you find the documentation for regular expression? Let's clean up the code a little bit. So you look up the function documentation for replace string replace. Okay, then it will point you to regular expression documentation in Wolfram language. Yeah, let's do it quickly. So Wolfram language string pattern, they support two methods to represent more than two methods to represent a pattern in string. One is regular expression, just like every other language, Golang, JavaScript, Python, Perl, or Bash, grep, regular expression you are familiar with. But they also support their symbolic pattern matching based syntax to represent patterns in string, which is, I haven't looked into detail, but I believe it's far more powerful than regular expression because it can represent string patterns that involves nesting. Regular expression, by definition, by the original, automata, linear grammar definition of the history of regular expression, by the very definition of regular expression, it is designed to match patterns that's only linear languages, no nesting. So regular expression is this, that's why it's called regular expression. If you have a language whose syntax involves nesting, such as Lisp or any kind of brackets, then that's not, the language it's called not regular. I mean, something like that. I forgot the detail. I might get the jargons wrong. But anyway, that's what regular expression is for linear languages only, no nesting. So when you have nested syntax such as paren or bracket, you cannot, or HTML, you cannot, or JSON, you cannot use regular expression to match them. It's only good for matching linear grammar. So Wolfram language supports regular expression. Let's look at some of them instead of me just talking. The Wolfram language supports regular expression, but they also support Wolfram symbolic pattern matching based pattern. Okay, so the syntax is obviously different. So there are so many documentations. So let's begin here. Okay, there it is. So you see, this page is a guide on string patterns. Now, this page is talking about what I was talking about, string expression. So this is a more generalized string pattern, far more powerful than regular expression. So they show you what the syntax here is. Now, I never used this before, so let's not use this. Let's go to regular expression here. Okay, so before we do that, let's copy that, go to talk show. Good morning, West, and go to talk show and paste some of the documentation here we talked about. Okay, so click on regular expression, copy the URL back to Emacs, show pink window, paste it here, linkify combine them into a list showing browser. So here, Vivaldi bug, they don't update the URL. Let's refresh now. Okay, now the URL is correct. Fuck Vivaldi, we talked about that yesterday. So let's do that. Showing browser. So you can see there's a link to string patterns, then there's link to regular expressions. They are all patterns of a string, but one is the traditional regular expression. So now click on regular expression. So this is how you represent regular expression in Wolfram language. Now this regular expression I know so well, so I don't need to read the documentation for it. Let's just go to it. So let's start to write regular expression here. Okay, so the bracket, then what is the pattern you are trying to match? The pattern we are trying to match is this. Okay, copy that. Okay, so the pattern we are trying to match is this. Okay, so let's do it one thing at a time. So ignore the link text. Let's just focus on fixing the domain name. Okay, so here's the pattern. So let's copy that pattern. Now we need to escape the quote because we need to put a quote outside of it. So there's a key. There it is. Okay, now put a quote on the whole thing. Cut it. Now put it here. Okay. So here is the pattern. Now that's not done yet. Okay, so here over here it's gonna be, let me show you. Okay, let's copy that. Let's copy that here. So here it's going to be anything and capture it. Okay, any character that is not double quote. Okay, one or more. Okay, yeah. So we want to capture this pattern, that begins with a href equals to, then a quote, http://saudi.info, then whatever, then up to the double quote. Okay, that's what we want to capture. Then the file access date we also need to capture. Okay, so we need the date. Okay, so we need the date we need the regular expression syntax to capture the ISO format of date. Okay, so let's do that. So I already have a shortcut, date t. So that is the, that's a Emacs abrib. If you haven't learned Emacs abrib, you should. Okay, so just search for Xali Emacs abrib. So for example, I can show you right now. So search for date. So there it is. You see that line? So I just type date t, that expand to the regular expression for the ISO format date. Okay, so we got this date. Now this date needs to be placed here. Okay, so that, let's double check. Now we don't want the backslash parentheses because that's Emacs thing. That's a Emacs toothpick syndrome. You don't need the backslash before parentheses. Yeah, because in regular expression, parentheses means capture. In Python, Ruby, JavaScript, Golang, Java, all languages. Except in Emacs Lisp, parentheses is literal. So if you want to capture, you need a backslash in front. In fact, you need two of them because backslash by itself is a meta character. So Emacs regular expression is a pain in the ass. So anyway, so we got the date pattern. Then then let's remove that. Okay, so that's our regular expression. Okay, cut it. Let's go back here. Let's go back here. Now the replace string, there it is. So replace string takes 2 arguments. Then the second argument is going to be a regular expression. And then you need a return, the replacement string. So replacement string will be, okay, the replacement string will be, I know regular expression well. The replace, okay, here's a complexity. The replace string needs to be computed because the regular expression captures the domain name. But now we need to convert that domain name to a full file path. Then we need to convert that full file path into a relative path. So we cannot have a replace string right here. So instead of, we need a function. In order to do that, I need to look up how to, so this is actually, the problem is not so simple. God, I think I'm gonna stop. I'm gonna chicken out and stop here because now, in order to do this, what I have to do now is first to, we are gradually getting closer, but in order to do this, I need to first of all write a function that takes a domain name, returns a full path. Okay, so let me just put in a template a function that takes a domain URL, change it to local file full path, and change it to relative path, and return that here. Okay, that's what we need to do. So copy the whole thing, go back to the Wolfram language, Wolfram notepad, select all, paste it. So maybe you can see better so far our code. Again, the task is about, I said, it's mentioned here. For each, anyway, you can read it. So back here, so now we need to write a bit digression, like a small job, write a function. Let's write it, okay? So write a function. Let's write it here, okay? Domain URL to relative path, okay? Takes a URL, return, let's write 2 functions, okay? So domain URL to full path, okay? Return a corresponding file full path. Okay, that's one function. Now we need to write another function, get relative path. Okay, this is already probably built in. So relative path, take a full path and return a relative path. Okay, now it takes 2 arguments, one full path, one the path. Okay, return a relative path a full path relative to the path. Okay, so we need to write these 2 functions. So let's write the first one. So the first one, function argument x path body, what the body will be. Okay, so the body will be replace string. Okay, string replace. Okay, the body will be not string repeat. Okay, string replace. Okay, string replace. The first argument is a path. The second argument is okay. This, let's clean this. Okay. So string replace, the first argument, the string you want to replace, that's a path. Then you want to replace by regular expression, whatever that. Okay, not even regular expression. You want to replace HTTP, just delete that. Okay, we don't need that. So replace this part by there. Okay, so let's see. So again, Wolfram mod doesn't have indentation. I need to, so the code is hard to read. Okay, copy the whole thing back to Wolfram notebook, paste it. So you can see we define this function, domain URL to file path, and we defined it here. This is a doc string. Okay, so let's see. Function path. Function takes a path and do a string replace. Okay, replace path by use the regular expression. Actually, we don't need regular expression. It's just a string. Okay, so not regular expression, just a string. Okay. Copy. Paste. Okay, so yeah, so that let's run it, see if that works. Okay, wait. Yeah, okay, I don't know what the code is doing. This is an interim code. So anyway, but we can test this function by itself. So let's try it. Let's try to call this function and give it a path. Oh yeah, xali.info. Okay, hold on a second. So copy that. Okay, so domain URL to file path. Now let's see. For example, this is our domain. I mean, this is a domain name. Wait. For example, that's a file. It should return a file path. Let's do it. Fantastic. Is it correct? Yes. Yep, that's fantastic. So we verified this function works at least. Okay, so delete that. Okay, so this function works. Now we need to now let's write a function that gets relative path. So given a path, file full path, you want to get the relative path. Now that function is already built in. So let's just look at my Wolfram script tutorial. So you want to find the relative path. Search for it. There it is. Expand file name. Okay, that's not it. Okay, where's relative path? File name take, file name drop, expand file name. You want to given a full path and given a directory, you want to get the relative path. Yeah, okay, so I don't know. So regular expressions, let's go to close that. Let's go to Wolfram documentation, read string, date object. Let's copy that to our talk show because we didn't before. There, okay. So read string date object document not found. Now I need the relative path. So how do you find the built-in function for relative path? What are we doing? Are we sure? Yeah, we given a full path and given a directory, you want to find the relative path. Okay, so right now we need to find the function. So to find a function, all you have to do is to find some function related to file. So because then, or you can just go to the Wolfram, not there, documentation center, graphics, math functions, images, knowledge representation, sound and video, graphs and networks, graph theory, symbolic and numerical computation, no, data manipulation, no, core language, okay, machine learning, maybe in core language, text and string, okay, maybe there, click on that. Wait, system operation and setup. Okay, let's say text and string. String manipulation, working with templates, text manipulation, text analysis. Okay, no, what we want is functions related to file manipulation. So core languages, parallel computing, external operations, import, export, file names. There it is. External operations, okay, then file names, okay, here, then you go down, then there's related guide, file operations, okay, then files, okay, let's click on files. Read string, write string, read the content of the file, read byte, import, export, read list, find list, file names, read write, read line, find, get, put. We need relative path, okay, file names, okay, that's not here. Remote file, okay, go back. Now let's see file operations. Rename file, delete file. Absolute file name. Click on that. You know, the easiest way is actually to search relative. Just type in relative. Relative path, there it is. Oh wait, this is one of the library. Yeah. So this one, you know, Wolfram library, you know, in typical programming language libraries, Perl, Python, Java, Ruby, a library is usually a bunch of functions. But in Wolfram language, they have a more refined notion. So you have a single function as kind of library. So they call it Wolfram function repository. So they also have libraries, but you also have one single function repository. So I can right now I can I can call this remote function by, but I don't like that because, so anyway, this function relative path is contributed by a Wolfram research, a programmer at Wolfram Research. I don't know this guy, Richard Hennigan. So I would trust this code, but however, I can write it myself. I can write it myself. I don't want to use. But in any case, I don't think you need external function. I'm pretty sure it's built in. It's just that. What's our search result? Let's go back. Okay, let's go back. Search result. I would be very surprised if the relative path function is not built in some shape or form. At most, it'll just require like 2 function calls, something like that. Hello, Kasai and friends. Hello, Alan. Hello. I think I'm gonna shut down. It's this coding problem is fairly tedious. I think I'm gonna shut down. So it's been an hour now. Wait, how long has it been? An hour and 20 minutes. So right now we are trying to find how do you get the relative path in Wolfram language. Well, the very existence of this function in repository, that probably means this function is not built in. I'm amazed. Yes, I'm amazed about. I'm surprised by this. So, but however, this function can be written in just 2 lines of code, one single line of code. So I want to write it myself. I'm not going to, use a cloud or import it. So, but before we write it, it's pretty simple. It's very simple. But can we look at the source code of this? Is there a source code? Detail and options. Okay, examples. Example notebook. Source notebook. Oh, you can actually, yeah, there it is. So you can actually see the source code. There it is. Yeah, I'm not gonna use it. I can define it better. Let me show you how. I mean, that's a stupid remark. I shouldn't say that. But okay, I don't want to look at it. Okay, so let's do this. Let's write a relative path function and that'll be it for today. Okay. So let's write a relative path function and that'll be it today. So relative path, you're gonna write a function now equals to function. Okay, then the function argument is 2 arguments. Okay, the first one is a full path. The second one is the path. Okay, then what is the body? So here is the body of the function. Now, so we're gonna write this function, but before we do, let's go back to some Xali website so we get a sense of the path arguments. So for example, here is a path. So for example, that's my let's use a Emacs block path. Okay. Okay, so now let's open that and let's go to some other path. Okay, let's see this one. Okay, so that's an example of two paths. Now so example of a path. Example of input path. Example of the, okay, the relative to, okay. Result should be, let's see what the result should be. The result should be, so this path relative, so that should be, the result should be, wait, so this is the input path relative to that the, okay. So the result should be dot 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 dot, okay, dot dot, yeah. So here is the result, okay. Yeah, so given that in the directory, the result should be, so what you do is you valley moment. What is valley moment? So what is the algorithm to get the relative path? Actually, thinking about it, I don't think I've ever coded this, because in EMAG-Lisp, in Python, in Perl, in Golang, I don't know about Golang, but Python, Perl, EMAG-Lisp, they all have a built-in function that returns a relative path. So, so anyway, so yeah, so I don't think I've wrote this before. But anyway, so given a path and given a directory, you want to return a path that's relative to the directory. So what you do first of all is to subtract the same beginning part of the string. Yeah, okay, so let's write down the, so notes. Find a string that's a common beginning of full path and the path. Okay, that's one of the first thing to do. Then you have to count the slash in the path, okay? Common root, that's a string. So level root is a count slash in common root, okay? Then level the path is a count slash in the path. And level input path Okay, level input path is count slash in the full path. I'm getting distracted. It's taking long time, and now I'm losing. Okay, so what do you do? What am I doing with all these slashes? Okay, so you want to count the slash, so you count the slash, then example of a directory. Oh God, now I want to look at the source code. It would be much faster if I just look at the source code. Okay, let's. I want to finish this. I hope to. But okay, so I have to think. First of all, I have to think. So the input path. So the example of input path. So let's not name it full path. Input path. They are all full path. Okay. Example of input path. Example of the path. Okay. So input path, for example, equals to the results, for example, equals to, and this is the example algorithm nodes. Okay, so input path, the path. So given directory. So if the input path is a subdirectory of the path, then obviously the relative path is whatever the input path minus the path. Okay, that's one idea. Then just input path minus. Okay, that would be the answer. Now, if input path, now the other case, if the input path is the, no, obviously not. So the input path, is a subdirectory, okay? Now, if they are the same directory, now if input path and the path are the same, then result is file name of just the file name part of the input path. Okay, wait. Okay, that's one case. That's a second case. Now, if the input path now the third case, if the directory path is a subdir of input path, then then it's problem. Then you need to add // to get to the same level as input path, then add the rest of input path. Okay, that's essentially the algorithm. Okay, so these three cases, you know, basically we want to count. That's why we are counting the level of the. So let's rewrite this part. Okay, so input path level count slashes. Okay, so we need the path level. Okay, count the slashes. Then level difference equals to minus okay, so we know the level difference. Then we can find out which case is what. I think I want to stop now, because now it's gonna longest common subsequence. That's is that a Wolfram language function? What is this? Safari. No, that's not a Wolfram language function, but oh, there it is. Longest common subsequence. Find the longest continuous subsequence of elements common to strings. Biomolecule sequences. Yeah. Okay. That can work. Actually, I'm getting tired, and this problem is not solved, but we talked almost like 90 minutes and 2 hours. I think I'm gonna stop. GitHub Copilot is no good. Okay, that's marketing crap. I talked about earlier. I commented. Yeah, too long. I gotta go. I have to go in. I have to go in today. I gotta run some errands. So that's it for today. The walk-in session kind of incomplete. So let's close in 5 minutes. Let's summarize what we did today. So let's make the code clean. Let's clean up our code so that we have a nice summary of what we did today. Okay, so copy that. Copy that. Text processing using Wolfram is for the brave. Actually, I think it's very good. A Wolfram language for text processing. It's just that I haven't used it to do that. So this is what the code we did today. Let's double check if so this is algorithm comments, what we need to do. So actually, so the Wolfram comment is a little problem. Let's do it again. Select all, paste. yeah, Wolfram comment, they just there's no line break unless I add line break myself. Let's see. Select all, paste. Did we actually line the line break? Result equals to. No, it does not respect the line break. Yeah, that's common. That's Wolfram comment because, and if you call them into standard form or whatever, it actually remove the comments for you. It just remove the comment. So the comment in Wolfram language is actual real comment. I mean, like it's basically ignored, and when you reformat the code, it delete them for you. So Wolfram comment is not reliable. I mean, it's not persistent, the comment in the Wolfram language. So anyway, that's digression. I've been trying to find some other way, but I don't think there's another way. But anyway, so here's our code. So let's remove that here. Syntax correct, show today's talk show. So that's what we talked about today. Show it. This is the problem we set out to do, and we did not complete. And so far, our code is like that. We have code to get all files in a directory of HTML files. We have shown how to write a inline documentation, how to write a function, how to do string replace. Yeah, this worked. And how to open a file, read the contents, and how to get the directory path of a full path. How to use regular expressions. We also explained how to, you have more advanced string patterns than regular expression. Yeah, that's what we talked about. But we have not finished coding this task. Yeah, that task is actually not easy to do because I've done that in Emacs Lisp. Let me show you. It takes half a day of today's task because then you need to get file name of a file, of the HTML title of a file. It's a bit involved because the heart of the complexity is that for thousands of files, HTML files, you open each one of them, and for every file, you check using a regular expression. For every, you check the form. Once you got it, you want to replace it, and you cannot directly represent the replace string because you need a function to compute the domain name. And in order to do that, you need the current file it's processing. Conceptually, it's not too complicated, but it actually takes a whole day to code it, half a day or code the whole day. So let me show you my Emacs Lisp code. For example, let me show you my Emacs Lisp code. So go to, where do we go to? So let's go to a XAR directory. So let's see. So one of these no, not that one. Okay, let's go to to-do. Okay, show in browser. Go back here. Let's see. So let's search for XX. Yeah, so it's in Emacs package. Okay, so it's this code. Okay. Wait, is it XAR HTML? No, it's not that one. Okay, let's go back to XAR brief. Let's go to XAR init. Then search for XAR site. There it is. Okay, Emacs XAR site, sitemap, site move. This file. Okay, let's open it. Yeah, this is the file. So this file is written in 2012 when I did a massive migration of my website into different domains. I split xarly.org 7,000 HTML files into 6 domains. So when you do that, you move thousands of files into different directories. Then you need to recompute all the relative links depending on whether they are in the same domain. If they are in the same domain, then you just use relative links. If they are in a different domain, you need to use fully qualified URL with domain name in it. HTTP / blah blah blah. So this Emacs script is written in 2012 when I did that, and it's working. But over the years, something broke. So this is only 250 lines. Something broke. And it took me a long time. It actually took me a week or a month to write this, because when doing this, there's a lot of complexities. So anyway, so here's the Emacs code. So that does basically what we are trying to do today. And you can run this script by giving it a list of files, like thousands of file names, where they are moving from and moving to, and run a script. It'll fix the links automatically. So this is actually much more complex than what we are doing today. For example, this is very old. This is ancient. So for example, this line, that means there's 2 parts. The first part is the original file path. So this is a file path, bad girl thumbnail, bad girl drawing. And the second part is where it moved to. So you have the origin file path and destination file path. Then this script will move the file and fix all the links in that file. Very involved code. So here is a function, XAR site fix HTML links. Takes a host file path, move from to list, moved from path, and write to file. Okay, that's it. Bye, guys.